Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Training Data Selection and Preparation. Training data selection and preparation is a crucial phase in the development of generative artificial intelligence models. The quality and relevance of training data significantly influence the performance and accuracy of AI models. In the context of the GenAI lifecycle, this phase involves meticulous planning and execution to ensure that the data used aligns with the intended outcomes of the model. This lesson delves into the intricacies of training data selection and preparation, highlighting its importance, challenges, and best practices. The first step in the process is understanding the problem domain and defining the objectives that the AI model aims to achieve. This involves a thorough analysis of the model's purpose and the specific tasks it is expected to perform. By clearly defining these objectives, data scientists can identify the type of data required and the characteristics it must possess to train the model effectively. This step is crucial because the relevance and quality of the data directly impact the model's ability to generalize and perform accurately in real-world scenarios. Once the objectives are clearly defined, the next step is to source the data. This can involve collecting new data, leveraging existing datasets, or a combination of both. When sourcing data, it is important to ensure it is representative of the problem domain and covers the full range of scenarios the model might encounter. This requires a balance between diversity and specificity. For example, a GenAI model designed to generate human-like text should be trained on a diverse corpus covering various topics, styles, and languages to ensure its outputs are coherent and contextually appropriate. However, the data must also be specific enough to avoid introducing irrelevant or misleading information that could degrade the model's performance. Data quality is a paramount consideration in this phase. Poor quality data can lead to biased models, inaccurate predictions, and unintended consequences. Therefore, it is essential to assess the data for errors, inconsistencies, and biases. This involves cleaning the data, which may include removing duplicates, correcting inaccuracies, and filling in missing values. For instance, in a dataset containing textual data, it might be necessary to standardize formats, correct spelling errors, and remove extraneous symbols to ensure consistency and coherence. Beyond cleaning, data pre-processing is another critical step in preparing the data for training. Pre-processing transforms raw data into a format that is more suitable for model training. This might involve normalizing numerical values, encoding categorical variables, and tokenizing text data. The goal is to create a dataset that the model can efficiently process while retaining the essential information needed to perform the task at hand. A well-prepared dataset facilitates more effective learning and enhances the model's ability to generalize across different inputs. Another important aspect of data preparation is addressing class imbalance. In many real-world datasets, certain classes or categories may be overrepresented, leading to biased models that perform poorly on underrepresented classes. Techniques such as oversampling, undersampling, or generating synthetic data can help balance the dataset and ensure that the model learns to recognize and respond to all classes effectively. For example, in a sentiment analysis task, if positive reviews are overrepresented, the model might become biased towards predicting positive sentiments. Balancing the dataset helps mitigate this risk and leads to more robust and fair models. Feature selection is another critical component of data preparation. It involves identifying and selecting the most relevant features or attributes that contribute to the model's performance. This step helps reduce the dimensionality of the dataset, which can improve the model's efficiency and accuracy. Feature selection can be achieved through various methods, such as correlation analysis, mutual information, or using domain knowledge to identify key attributes. By focusing on the most relevant features, data scientists can reduce noise and improve the model's ability to learn meaningful patterns. Once the data is prepared, it is essential to split it into training, validation, and test sets. This step is crucial for evaluating the model's performance and ensuring its ability to generalize to new, unseen data. A common practice is to allocate 70% of the data for training, 15% for validation, and 15% for testing. The training set is used to train the model. The validation set helps tune hyperparameters and prevent overfitting, and the test set provides an unbiased evaluation of the final model's performance. This approach helps ensure that the model is robust and performs well across different datasets. Throughout the data preparation process, it is vital to document the steps taken and decisions made. This documentation provides transparency and reproducibility, allowing others to understand and replicate the process if needed. It also helps identify potential sources of error or bias and provides a basis for refining and improving the data preparation process in future projects. In conclusion, training data selection and preparation is a fundamental step in the development of GenAI models. It requires careful consideration of the problem domain, data quality, pre-processing techniques, and feature selection to ensure that the data used is representative, unbiased, and conducive to effective learning. By following best practices and leveraging domain knowledge, data scientists can create robust datasets that enable AI models to perform accurately and reliably. This process not only enhances the model's performance, but also contributes to the overall success of the GenAI lifecycle. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.